All right, so picking up where we left off with quadratics. So we did vertex form, we did standard form, continuous standard form. We're going to add in this concept of intercepts, but all the other stuff is still going to remain the same. So given our equation, y equals x squared minus 4x minus 5. So we want to find our axis of symmetry, which remember is x equals negative b over 2a. And we get our a, b, and c from right there. So our b is a negative 4, and our a is 1. So two negatives make a positive 4 over 2, which is 2. So our axis of symmetry is x equals 2. Remember, in order to find our vertex, what we want to do is we want to substitute that value back in. So this 2 is going to go in for our x's here. So we get y equals 2 squared minus 4 times 2 minus 5. 2 squared is 4. Negative 4 times 2 is a negative 8 minus 5. And 4 minus 8 minus 5 is a negative 9. So then our vertex is going to be 2, negative 9. So let's do a quick sketch just so we know what this graph kind of looks like. So I'm going to plot 2 and negative 9. And since our a is positive, we know our graph is going to open up. So this is just a sketch. We didn't make our table be more accurate. We just want to sketch so we have a general idea of what's going on there. Now find our y-intercept. Now, to have a y-intercept, that's when we cross the y-axis, so somewhere in that area, which means then our x is 0. So we would substitute 0 in for x. And we simplify that out. 0 squared is just 0. Negative 4 times 0 is just 0. So then our y-intercept is a negative 5. So we would write that as 0, negative 5. Domain, negative infinity to positive infinity. And our range is going to be from our vertex, which is negative 9. And it's going up, so we're going to go to positive infinity, which means we have a minimum at y equals negative 9. All right, so using zeros to solve quadratic equations graphically. So a 0 of a function is an x value that makes the function 0. Right, so essentially that our y ends up being 0. So the zeros of a function are the x-intercepts of the graph. And a quadratic function may have 0, 1, or 2 zeros. So we want to solve by graphing. So first thing we want to do is rewrite the quadratic equation so that equals 0 on one side. So I'm going to add 3 over. I'm going to add 3 there. And so we get 2x squared minus 2 equals 0. And then we want to make a table of values to graph the function. So this is essentially as if we had y equals 2x squared minus 2. So we want to pick our values in our table. We look at this, and so x equals negative b, which there is no b value, over 2a. So we get 0. So we know our vertex is at 0. So I'll put that there. And then let's go 1 point on each side. So as we substitute those in, we get y equals 2 negative 1 squared minus 2, which is positive 1 here, and then 2 minus 2 is 0, so we get 0 for that one. Now we'll do the same with 0, substitute that in. So we go 0, 0 squared is 0, 0 times 2 is 0, and then we get negative 2 there. And then we do the same thing with 1. And then we get 2 minus 2, which is 0. So as we go to plot this, we get negative 1, 0. We get 0, negative 2, and 1, 0. And then there's our graph there. And so the solutions are the x-intercepts. So our solutions are x equals negative 1 and 1, or x-intercepts are negative 1, 0, and 1, 0. So that one worked out nice. It just happened to be those on each side. All right, let's do this third one here. So I'm going to add x squared over. There are no like terms, so we get x squared plus 6x plus 8, and that equals 0. And for graphing, we can go y equals x squared plus 6x plus 8. Identify our vertex. So we get x equals negative b, which is 6 in this case, over 2a, which is 1. So we get negative 6 over 2, which is negative 3. So make our tables. And so I have x and y. And we had negative 3 here, so we'll go negative 4 and negative 2. We'll substitute those values in, so we get y equals, let's start with negative 4. So we get negative 4 squared plus 6 times negative 4 plus 8. Negative 4 squared is 16. 6 times negative 4 is a negative 24. And then plus 8. Add that all up, and we get y equals 0. And then we have our negative 3. So I'll substitute that in. So negative 3 goes in here. Negative 3 squared is 9. 6 times negative 3 is a negative 18. So we can go and add those together, and y now equals a negative 1. And as we talked about, remember these are mirrored, so if that was 0, this one's going to be 0. So as we go to graph this, we have negative 3, negative 1, negative 4, 0, and negative 2, 0. And there is our graph there. Okay, so our solutions again is where our y equals 0, so when x equals negative 4 and negative 2, or as it intercepts negative 4, 0, and negative 2, 0. All All right, so we want to do that with this whole thing here. So we're going to start all the way from beginning, do all the parts we've done, and then we're going to add in our intercepts as well. So again, get this set equal to 0, so I'm going to add 17 over. And that's going to give us 0, or y equals x squared plus 8x plus 12 for our equation. So our axis is symmetry, x equals negative, our b in this case is 8 over 2a, which is 1. So it's negative 8 over 2, which is negative 4. So our axis symmetry is x equals negative 4. Take our vertex, we're going to substitute that in, so that negative 4 goes into the equation. We get y equals negative 4 squared plus 8 times negative 4 plus 12. So we get 16 minus 32 plus 12. And simplify that. And so y equals negative 4. So then our vertex is negative 4, negative 4. Sketch the graph. So we have negative 4, negative 4. And then our a value is 1, so it's positive, so we know a quick sketch, we're going to go up. Okay, so for our y-intercept, and we substitute 0 in for x, so we get y equals 0 squared plus 8 times 0 plus 12, so 0 and 0, so y equals 12. So our y-intercept is at 0, 12. And then so for our x-intercepts, we do our table. And we get negative 4, negative 4 for our vertex. And we pick points on either side, so we'll go negative 5 and negative 3. Substitute those in. So we get y equals negative 5 squared plus 8 times negative 5 plus 12. So that gives us 25 minus 40 plus 12. So then we get negative 3. And then we know this is negative 3. Well, that didn't give us our 0, so we need to pick some more points. So we'll go some more points on each side. So adding on, let's erase this x and y up here. And we'll add in negative 6 here. And let's go negative 2 here. And so instead of that negative 5, we'll put in a negative 6. So negative 6 squared is 36. 8 times negative 6 is a negative 48. And when we add that together, that now gives us 0. And then we're mirrored. So then our x-intercepts are going to be at negative 6, 0, and negative 2, 0. Our domain, as always, negative infinity to positive infinity. Our range, starting and going up, so we're going to start at negative 4, and we're going to go to positive infinity, which means we have a minimum at y equals the y value of our vertex, which is negative 4. Okay, for number 5, go ahead and try that one on your own. We'll discuss that in class. And then a reflect question, how would the graph of a quadratic equation look if the equation has 1, 0, So answer that. We'll discuss that in class. Do your quizzes and then your essential question. And we'll do our homework when we come into class.